Okay, so this is just a little explanation about four-sided shapes and the definitions. And when we look at the definitions of certain four-sided shapes, we realize that some of these four-sided shapes are fall under the umbrella of another four-sided shape. In other words, if you look at the example of a rectangle by definition has four internal right angles, okay, and each pair of opposite sides are equal length. Okay, like that. That it doesn't say so, but it also has each pair of opposite sides will have to be parallel because of that too. In any case, that definition also fits the description of a square. A square also has opposite sides that are parallel and equal length, has four internal right angles, and the other two are also equal in length to each other. They're just also equal in length to all four sides are equal in length. So, in other words, a square is a rectangle, but a rectangle is not necessarily a square. So, this can be demonstrated with this simulation, which you can find from Math is Fun. This is a rectangle, and as I move it around and try and change it, however I move it, it's always going to be a rectangle. The other points move, so it always makes a rectangle. But you'll see that I can, if I want to, if I fiddle around with it enough, I can make a square. I can't say for certain that is a square, but you should hopefully be able to see that if I can do that to that, I can definitely make a square. So we can say that a square is a rectangle, but a rectangle is not necessarily a square. This diagram shows that apparently a rectangle is a parallelogram, but not the other way around. A parallelogram is a trapezium, but not the other way around. And a rhombus is a parallelogram, which is also a trapezium, but not the other way around. Why is that? Well, a parallelogram, two pairs of opposite sides are parallel, but they don't have to be the same length and they don't have to have right angles. So the other two fit that description. It doesn't say that they can't be right angles. It just says that they. It doesn't specify whether or not they are right angles. So if I choose a parallelogram here, you can even notice actually these three options are indented and under the parallelogram. So already, in fact, if I go to square, then click on parallelogram, it doesn't change. That's highlighting that they can be the same. If I go to square and go to rectangle, it doesn't change, right? I go to rhombus, and it also doesn't change. Oh no, it does. Hang on. Okay, so rhombus. I think actually a rhombus can also be a square. I'm not sure about that one. Square. Yeah, okay. I think a rhombus can also be a square. So I'm actually going to, change that bit there. So, but a rectangle isn't a rhombus. So let's go back over this a little bit more. A parallelogram is, we know it to be like this, like a sort of, imagine a rectangle that's been sort of squished, like the top and the bottom has been slid to one side. So we see a parallelogram and we imagine it looks like that. But you can see I can make a square out of it, or a rectangle, in fact, if I play around with it enough. So a rectangle is a parallelogram. A rhombus is basically, as it said, like a square that's been squashed. All the sides are equal in length, but we don't have to have right angles. Okay? But when we do this, it will always be such that the opposite lengths will be parallel with each other. Opposite sides will be parallel with each other. That's why a rhombus is also a parallelogram. What about a trapezium? A trapezium just needs to have one pair of opposite sides that are parallel. So in this case, the top and the bottom are parallel. Of course, it could be the left and the right could be parallel, but in this example, the top and the bottom are parallel. So if I choose trapezoid, it didn't change anything. That means that a rhombus must be a trapezium. If we go to a rectangle, just make something out of it and click on trapezoid, doesn't change again. That's because a rectangle is also a trapezium. But it has to be a trapezium because it's a parallelogram, and parallelograms are trapeziums. So I just click on parallelogram and make a standard parallelogram. Click on trapezoid, doesn't change. Because all that you need to do to fit the description of a trapezoid is to have two opposite sides that are equal in length. A kite doesn't fit any of them, although actually a rhombus. Let me just have a look at this for a moment. Okay, so actually looking at this, the shape has an axis of symmetry like that. One axis of symmetry, not that one. And that two touching sides are equal in length, and these two are equal in length. So that means a rhombus is also a kite. But a kite is not necessarily a rhombus. And we also know that a square is a rhombus, and so therefore a square is also a kite. But a kite is not a trapezium. So these the trapeziums and the kites are kind of over, more general words. So a kite would describe this kind of kite, but it also describes a rhombus and a square. A trapezium would describe all these four things, but not the kite. And then you just have other things like isosceles, like trapezium, which just means a symmetrical trapezium. So if we just go to trapezoid, which is just the American English for trapezium, I don't need to make it symmetrical. Okay, I could make it symmetrical if I wanted to. If I can work out how to do that. It's a bit fiddly, isn't it? I think I broke it. Okay, all right. Oh, okay, fine. I can't work out to fiddle around with it. But okay, that one probably looks like it's going to be symmetrical. A line of symmetry down there. So that's something which I wanted to make clear.